Department of Biotechnology and Medical Engineering of National Institute of Technology, Rourkela, was established in the year 2007 with the future goal of producing quality engineers by offering multidisciplinary teaching and research, developing world-class resources, and in making outstanding contributions in the realm of biomedical and biotechnology, a goal it has been achieving at a rapid rate. The department is divided into two streams, biotechnology and biomedical. There are six academics and research groups. Currently, a cadre of faculty members from diverse fields have been appointed for carrying forth the department. The department is MBA accredited. We have various state-of-the-art labs too. Cell and molecular engineering. Achievements of the department include Center of Excellence in Tissue Engineering and Orthopedic Tissue Engineering and Rehabilitation, DBT Program Support in Tissue Engineering, Program Support in Bioinformatics, DSF FIST Level 1. Bioprocess Engineering. Agricultural and Environment Engineering. Biomechanics and Biotransfer. Biomaterials and Tissue Engineering. Medical Electronics and Instrumentation. The department also has an active technical club, Genesys, registered under the Technical Society of Student Activity Center, NIT Rourkela. The club conducts several activities around the year. The department also organized a biotechnology popularization and skill development program. The program aimed to motivate the school children to pursue a career in biotechnology. Various activities such as tree plantation, vermicompost production, sanitation, health camp, sustainable agricultural practices have been performed in some of the nearby villages by the Unnat Bharat Abhiyan team of NIT Rourkela. The institute offers a total of 60 seats, 30 for each stream, for the undergraduates under the BTech program through Joint Seat Allocation Authority, direct admission of students abroad, Indian Council for Cultural Relations, and Ministry of External Affairs. Apart from BTech programs, the department also offers MTech 2 years and PhD programs to the graduates.
Hello. All right. Good morning, one and all. Genesys. Good morning, all, once again. Genesys, the official bioengineering club of NIT Rourkela, registered under SAC, NIT Rourkela, after its establishment in the year 2015 with an objective to spread the knowledge in the field of bioengineering, has so far been successful in conducting several technical and non-technical events to create awareness about this vast emerging field of bioengineering in today's generation. As it was said by Dr. APJ Abdul Kalam, difficulties in your life do not come to destroy you, but to help you realize your hidden potential and power. Let difficulties know that you are too difficult. Today, while we are struggling with this pandemic that has almost made it impossible for all of us to carry forward the ongoing researches and studies in the field of bioengineering, and also it has made it difficult for us to reach you all with our events. We try to put a little extra effort to bring to you a virtual exhibition, the GenXConference, organized by Genesys, NIT Rourkela, to spread the essence of bioengineering amid this pandemic. I, Monalisha Malik, the Secretary of Genesys, welcomes you all to the GenXConference 2021. To begin with, I'd like to quote, "Predicting the future isn't magic, it's artificial intelligence." One of the world's highest growth industries, the artificial intelligence sector, has now taken over in the healthcare sector as well, simplifying the lives of patients, doctors, hospital administrators by performing tasks that are typically done by humans but in less time and at a fraction of cost. Today, to begin with, the first session on artificial intelligence, we have with us Dr. Mirza Khalid Baig, sir, Assistant Professor from the Department of Biotechnology and Medical Engineering, National Institute of Technology, Rourkela. Dr. Mirza Khalid Baig, sir, pursued his PhD and postdoctoral research in neuromodulations and biosensors at Imperial College London. He also worked in engineer technology, United Kingdom, for 2 years after earning his master's degree, gaining industrial experience in product development. Later, he joined NIT Rourkela in July 2020 as the assistant professor. So, without any further delay, I'd like to welcome Dr. Sir to begin with the session.
Thank you, Mona Lisa. Uh, Good morning, everyone. Welcome to GenX 2021. First of all, I would like to thank the organizers of this beautiful conference for asking me to conduct this workshop. I feel honored and I feel very privileged. And actually, to be honest, this is my first time actually experiencing this kind of student activity. So I'm really very happy to see the kind of speakers that they have lined up for today and tomorrow. So it's an excellent of speakers, and I encourage all of you listeners to take benefit of it. Okay. So let's, without further ado, without any more delay, let me start today's session. It's essentially a workshop on artificial intelligence. Sasot, is it visible? Is the screen visible? Okay, maybe now. Right. So let's start. Okay, so the goal of this today's workshop is the kind of idea I had in mind was, as most of us, or let's say majority of the listeners, are from bioengineering background. So this particular topic, artificial intelligence, essentially originates from computer science. Okay, but but recently we have seen that it is penetrating this area. Artificial intelligence is penetrating many different sub-disciplines, or let's say disciplines, in various areas. So the premise I had in mind is that since we are all bioengineers, so artificial intelligence would be a new topic for all of us. So I will start with the basics. Okay, with this workshop, through this workshop, you will get the basic requirements to help you start off in this field. If you need to apply this if you want to work in artificial intelligence, or if you would like to use artificial intelligence for some of your projects, then this workshop, I hope, will be useful to you, because it will give you a starting point. Of course, artificial intelligence is a very vast field to cover entirely in one workshop. So I hope this workshop will be useful to you. So and it will actually equip you with the basic tools and requirements that are necessary to start off. Okay, so with this, let's have a look what we are going to cover today. So first of all, we look at what is artificial intelligence. Okay, so you may have heard quite a lot about it, but let's have a look at it from a scientific perspective, from a more technical perspective. Let's have a look at it. So where can we use AI? Okay, which type of problems that we can use? It's not that AI can be used anywhere and everywhere. There are certain problems where you can use AI. What are the requirements for this? For AI to be applied. So in which type of problems? Then how can we use it? Okay, how can we benefit from AI? How can we exploit the tools and resources that are available for us in this area, so that we are able to solve a problem or answer some scientific question? Okay, and finally, I will try to show you some examples, some demos, which will help you get an understanding of the step-by-step process. So overall, this workshop is about 1 hour long. The first half an hour will be more of a like presentation, half an hour, 45 minutes, and then the remaining time will be question answers, Q&A. Okay, and of course, feel free to ask or post any questions if you have. Okay, right. So I wanted, first of all, I put this screen over here. I wanted to ask you to guess the movie, but since it's in online mode and I think the platform doesn't permit that, so this particular movie is from this particular screenshot is from a movie called Alien Covenant. So if you are a sci-fi enthusiast, or if you really are into this kind of movies, then you may have watched it already. Ridley Scott is a director. And you see here in this picture, you have this person standing and then a person sitting here. The person is sitting here is not really a human being. It's an android. His name is David. And this guy over here, his name is Peter Weyland. So he's the owner, CEO, founder of Weyland Corporation, which makes these androids. Okay, and David is what we want AI to be in future: completely intelligent, it can think, it may have emotions, I don't know. So this is the kind of or let's say very close to what humans are in reality. So that's what the epitome, or that's the vision. And also that's the vision with which how people started off, people who were pioneers in AI started off with. So they wanted to build machines which can think like humans, which have the originality like human left. So we as human beings, we can have original thoughts, or let's say novel thoughts. So that is the idea. We want machines to have novel thoughts, ideas, which can originate from them rather than we telling them that you do this. Okay. Anyway, so that's one of the visions in AI. And of course, it is one of the fears in AI that the AI will become such an intelligent, let's say, being that it will try to overshadow or overcome human beings and try to rule us or whatever. That's the fear as well. But anyway, so these are some conflicting thoughts, ethics, and many discussions going on around in the world regarding this. Anyway, so I can tell you with say like we are safe. AI has not reached that level yet, but anyway, so let's see where AI is currently and how we can use it for our purposes. Okay. So artificial intelligence, what is it? What is artificial intelligence? So let me give you some historical perspective about artificial intelligence. So it has been a long time dream of humans to create machines that can think. So it all started off with two people in England, Charles Babbage and Lady Ada Lovelace. Okay, so they were collaborators, scientific collaborators. So Charles Babbage developed an engine. Maybe those of you, if you have a computer science background, you might know. So Charles Babbage developed a computer. I think he developed the first computational engine called the analytical machine. So it was a mechanical computational engine. So it wasn't working on electronics; it was mechanical. But so when Lady Ada Lovelace saw this kind of machine that Charles Babbage had built, so she made a comment. Actually, she made a comment in a paper, in an article, that I mean, I'm not saying the exact words, but I will tell you the interpretation. The interpretation is that she commented to the effect that okay, this machine cannot do anything which is novel or original yet, but it would be nice to have something like this. So there was a scientist called Alan Turing in 1950s. Okay, around somewhere around 1950, he published this paper called Computing Machinery and Intelligence. So Alan Turing was another pioneer in artificial intelligence. He was a computer scientist. So he took up this objection of Lady Ada Lovelace. The objection was that this machine could not think or produce anything novel. So in his paper, he tried to prove that yes, indeed, it is possible to build a machine which can have originality, which is capable of learning, and which can have the capability of originality. So it can have original thoughts. Okay, so that is, let's say, the birth of AI as we know today. So it started off somewhere in 1800s when this analytical engine was built, and from there we came to Alan Turing, and then this term artificial intelligence was coined by someone called John McCarthy. So John in 1950s, and of course he kind of tried to define the idea behind AI. So it was to create intelligent machines that have the ability to achieve goals like human beings. For example, as students, we have a goal to go into a certain career. Then we try to select the right path to achieve that goal. So the idea was if we give a goal to a machine, the machine will find the best possible way to achieve that goal without us having to tell the machine that, okay, you do it this way. Okay, so that was the idea, and that is the eventual goal, let's say, vision in AI. As you can see, AI is not something new which was invented in the last decade. It is something which has been around since 1950s. Okay, and a lot of research has been done. Today we will look into it and try to understand how it has progressed over the years very briefly. Okay, so we have this field called artificial intelligence. Okay, within artificial intelligence, we have another field or area, or let's say topic called subdiscipline called machine learning. Now, within machine learning, people also started to think, how can we develop algorithms which can think like human beings, think like neurons, think like the brain thinks. Okay, in the brain we have neurons, and can we design algorithms which can mimic the way in which the brain is thinking, the brain is working? Because the brain is one of the most efficient biological machines, computational machines. So that's why we enter into the area called brain inspired, or we can say neuro inspired or neuromorphic. Okay, so within this we have two types of subdisciplines or topics. One is neural networks. The other one is also, it's called spiking neural networks. So today we will look briefly at machine learning and a little bit about neural networks if time permits. But mostly we will focus on how to use machine learning for our applications. What are the different steps that we need to follow if we want to deploy a machine learning algorithm for our applications. Okay, right. So we saw that machine learning is a sub-discipline within artificial intelligence. So what is this? What is other? When did it start? Or what is the other? So it's, if you think of like a set, if you think artificial intelligence like a set, so machine learning is a subset. But there is some area which is outside machine learning. What is that? So it will tell you about the evolution of artificial intelligence over the years. Okay, so artificial intelligence from 1950s to until 1980s, it was something called symbolic AI, so, or symbolic artificial intelligence. So people believed for a very long time, so almost 3 decades, people believe that if we hard code or write programs with sufficient number of rules, then our program can be used to mimic a human being. Okay, so for example, early chess programs, we have these, you may have seen, if you are like, when you are small, you might have played chess with the computer. So this is not AI, like it is AI but not in the traditional sense, or it's not machine learning, or it is not. So this AI is far away from what you may have heard recently about a Google algorithm solving or defeating a human in a game called Go. So it's a far away thing from what we have in currently what we have. So essentially, it is a series of rules and regulations are hard coded, and the computer follows these rules and regulations to win a game of chess. Okay, so for a long time, people believe that just simply hard coding stuff will help us solve or will help the machine become like a human, but it wasn't true. So after 1980s, okay, so there another kind of field which was in the background gained traction. It was where, you know, people started developing computer programs which can learn from data. So essentially, if you provide machine learning algorithms with data, it will learn from the data and it will try to solve any particular task that is given to the program. So let's see how it is working. So how is an AI, or let's say, so now AI is broadly dominated by machine learning. Okay, this symbolic AI is out of the picture, almost out of the picture. Nobody is interested in it that much as people used to be in 1980s. So it's mostly machine learning where data is important, or data is at the center of the algorithm. Okay, so in a traditional classical program that you may have written in your first year or second year C program, it consists of some rules that is hard coded in the program, and that when you give some data, it will give you some answers. So that is a classical program. It relies on rules. Whereas opposed to classical programs, in a machine learning program, you give it some data. So data is crucial. Without data, your machine learning program will not work or will not function properly. And you may give some answers also which are linked to this data. So you may give some answers as well which may be linked to the data. So you may give, so data and answers may be linked or may not be linked. So it's not compulsory, but this is compulsory. In this case, rules is compulsory. And the machine learning program essentially relies on the data, and it produces a set of rules. And these rules will be specific to the application for which the data was generated. And then if any new data comes in, unknown data, then it will rely on this set of rules to make some kind of prediction, or it may use it to make some kind of classification. So essentially, machine learning programs broadly they perform two tasks. One is classification, the other one is regression. So we will see what are these two things. So classification is, let's say, you provide a machine learning program with some physiological parameters, and the machine learning program tries to answer or predict if a person has a disease or does not have a disease. So it tries to put things into class, and then we have regression where it is trying to predict a numerical value. For example, it will try to predict a stock price, it will try to predict some kind of, let's say, house price in an area. So that is a regression problem. And so we broadly have two problems that we try to solve using machine learning. Or let's say we try to, if we have a problem or application that we want to solve, then we gradually put it into, we put it either into a classification task or a regression task. Okay. Anyway, the important thing is data. So without data, machine learning program will not function well. So let's have a look little bit more in detail. So essentially, a traditional program we study the problem, then we write the rules for it, and we write the program based on these rules. Okay, so using these rules, it will evaluate if if our program is satisfactory enough to be launched or not launched. If it's not satisfactory, then we try to analyze the errors and study the problem again, rewrite the rules, and this is how a normal program works. But in comparison, so in machine learning, you study the problem, then you train the machine learning problem on machine learning algorithm. So you train this algorithm on raw data or data. Let's say we'll see what is raw data, what is features in data. We will look at it during the example. So you use data to train the algorithm. Then you evaluate the performance of a machine learning algorithm. So if it is satisfactory, we launch it. If not, we can use some better data, or we can clean up the data that we have here in this raw data, and then evaluate it again until it is satisfactory enough to be launched. Okay, so that is the machine learning approach, right? All right. So as I said, machine learning programs tend to learn from data. Typically, they go through two phases: training and validation. Okay, so the idea is, let's say if you change the problem definition, in a normal program, you may have to change the program itself. For example, let's say you are writing some kind of image processing algorithm to identify a cat in an image. Okay, so then you might have to hard code rules in your normal program to identify cats. But if you want to identify dogs, then it will be difficult. You have to change the entire program. So similarly here, in machine learning, actually what we can do here is, if we want to identify, just giving a simple analogy, that if we want the program to identify cats, then we provide data in which will consist of images of cats. Okay, so when the machine learning program generates a set of rules based on the training data, then if you give it an unknown image, it will be able to identify cats. Now, if we want the program to identify dogs, then we don't need to change the program. We just need to change the training data. So once we change the training data, the machine learning program will automatically adjust itself so that it will identify dogs in an unknown image. So this is a simple analogy just to understand what is the difference between a traditional or normal program and a machine learning program. So where can we use AI? Programs for which existing solutions require a lot of fine tuning, or complex problems, there we can use, and problems where it is like highly dynamic and fluctuating environments, for example, stock market or human body, or many different areas where we have the environments are fluctuating and the variables are changing quite a large number of times. So there we cannot use normal programs, or let's say it will not be efficient to use normal programs. So in those cases, we can use AI. Okay. Of course, there are problems where you need to, which involves large amount of data. So there also you can use AI to you, where you can use AI to solve problems where there is large amount of data to be analyzed. Okay. So what is necessary for an AI to work? Let's have a look. So we looked at what is AI and how AI progressed through the years, and then we looked at which problems we can, which are how AI works, what is the block diagram, or let's say step-by-step process, and then we can see where we are looking at where we can use AI. Now let's see, before we can use AI, we should check whether if our problem fits the prerequisites or the requirements of an AI, certain requirements. If our problem definition, or let's say if our problem fits certain requirements, then only we can use AI to solve our problem. So what are the prerequisites? First of all, data. This is the most important thing. There exists some kind of preliminary or experimental data. Without enough data, your machine learning algorithm will not train very well and it will not perform very well. So data is the most important prerequisite. Okay, second is there is some kind of pattern, and this pattern may be unknown. So we expect some pattern to be present within the data. So this pattern may be unknown, or we do not know the exact definition of the pattern. So it should be a difficult to formulate pattern. So we cannot easily represent the pattern mathematically. So if we know this function, if we can define the pattern using a mathematical function accurately, then we don't need learning or machine learning. We can just use that function to solve our problem. Okay. So these are three requisites. Essentially, the most important one is empirical data. So if data exists and there is some kind of pattern, you believe there might be some kind of pattern. Sometimes you may have to do some kind of exploration to identify whether there is pattern. So let's say you have data, and then the next thing to look out for is pattern. So if you see that there is some kind of pattern, yes, you can use AI to solve your problem. Okay. Okay, so from a mathematical perspective, how does it look like? So there is, today we are not going into more details of what is the but this is how, in mathematics people look at AI. So in AI or machine learning, there is a lot of concepts which have been borrowed from statistics, and some additional concepts have been added in machine learning. So what are the how people look at AI from a mathematical perspective. So this is important to understand in order to understand the thought process of the pioneers, let's say. So we have something called a target function. So the target function is a link between it's a link between the inputs and the outputs. Let me elaborate this a little bit more. So let's say we have some kind of training data. Let's say we have some kind of stock market or trading data. So within that training data, we will have some kind of a link. Okay, let's say we have two parameters. We did an experiment in which we changed the parameter y and we measured the results. We changed the parameter x and we measured the results as y. So in that experiment, we will have, for different values of x, we might have different values of y. Okay. So this is let's say we collected this data during an experiment. Okay. So these are all, we know that there is some kind of relationship between x and y. Okay, there is some kind of relationship between x and y. So there is some kind of mathematical relationship between x and y, but this relationship is unknown. Okay, this relationship is unknown. So this function is known as target function. So in machine learning, target function is always unknown. So that's why I said previously that if the pattern can be formulated mathematically, then there is no point of using machine learning. You can use mathematics to solve the problem, simple mathematics. But since we do not know the target function, we have to rely on training data. We have to rely on some data which we collected during our experiment. So let's say we change the parameter to x1, we change x to x1, and we got the result as y1. Similarly, we changed to x2 and got the result as y2. So like this, we collected our experimental data, which is our training data. Okay. Then we have something called a hypothesis. Okay. So what is a hypothesis? So hypothesis is another function. Let's call it G. Okay, so G is trying to approximate F. So hypothesis is trying to approximate the target function. It is trying to approximate the target function. So it's trying to get as close as possible to the target function. So target function is unknown, and we are using G to approximate the target function. So essentially, to define, let's say from a machine learning perspective, so this is our is the process that we are trying to understand. This is our machine learning algorithm. So hypothesis is our machine learning algorithm. Okay, which we try to approximate. So we use this machine learning algorithm to try to approximate the underlying process. So if you say what is learning, so learning essentially is using a set of observations to uncover some underlying process. So it's important. So learning, that's something we do as humans also in experiments. As scientists, we do using a set of observations to uncover some underlying process. So this is what we have been doing for a long time as scientists. So in science, we collect, we do experiments, we collect data, and we try to test our hypothesis. So similar process, thought process is here as well. We have an unknown function, or the unknown underlying pattern is unknown. Essentially, we can estimate it, but we do not know the exact relationship between x and y, and we try to approximate it using our function called G, or machine learning algorithm, or hypothesis function. So in real life, we can have a hypothesis set which consists of a list of machine learning algorithms. So I will be interchanging between these terms, artificial intelligence and machine learning, because essentially machine learning is a subset of artificial intelligence, and another part of machine learning, which is artificial intelligence, which is symbolic AI, which we do not use anymore. So most of the stuff that is happening is actually falls under machine learning. Okay. So anyway, so this we may have a hypothesis set, or it is a list of machine learning algorithms. Let's say support vector machines, or linear regression, or decision forests. Many algorithms are there. So we try each and every algorithm and try to find out which is the best one which works for our application. So once we find it out, we use it as our final hypothesis. Okay. All right. So in this learning algorithm, so how does it arrive to the final hypothesis? So to do that, it uses something called a cost function. So so it relies on the training data and uses something called cost function. It tries to achieve an optimal value of the cost function to reach the final hypothesis. Okay. So these are just some basic concepts which will help you start off with machine learning. Okay, so what are the different steps that machine learning algorithm goes through? Let's say you have your data. So we have an experiment, or let's say an empirical process. And within that experiment or empirical process, we have collected some data. And we believe that using this data, we want to apply, we want to discover the underlying process, or whatever, we want to make some predictions, or we want to do some classification basically. So what are the different steps? So this data, these are the different steps. So first is the machine learning algorithm. We rely on the existing data to undergo training. Then we do cross validation. We use cross validation first of all to test our machine learning algorithm is good enough or not, and then we can also use cross validation to optimize or tune our machine learning algorithm. Then we might provide it some unknown data just to test its performance. Okay, so that is called validation. And once we are happy with all these different steps, especially validation, so we can deploy this machine learning algorithm for our applications. Okay, so these are the 4 broad steps through which every machine learning algorithm goes through. You can pick any algorithm in any machine learning algorithm: training, cross validation, validation, and deployment. Okay, so what are the different types of learning that are present in machine learning? So one is whether it is trained through human supervision or not. So there is something called supervised learning. So supervised learning, essentially, I just briefly discussed. I gave you a simple example where you have two parameters, x and y. So you change x and you found out the y value. Okay. Similarly, you did this. So here we know the x and we also know the y. Okay. So we know the x and we know the y. And for this reason, we are actually, so we know this is we know the x and we know the y. So so this is where we use supervised. So this is called supervised learning. So where we have both. So in statistics we call this independent variable, and this one is dependent variable. So we have information about both the independent and dependent variables. So we have in our data set, we have the linkage between independent and dependent variables. So that's what we mean by human supervision. So supervised. In unsupervised learning, okay, so it's a very strange type of area in unsupervised learning where we just have data and somehow the algorithm has to figure out what is the underlying pattern. So this is something, I will give you a nice example which will help you understand the difference between supervised and unsupervised learning. And then there is something called semi-supervised, which is a combination of supervised and unsupervised learning. Okay, and then this is very interesting nowadays. Okay, reinforcement learning. So if you read about something called AlphaGo, okay, so this is a Google algorithm which was made by Google. It was trained using reinforcement learning, and it defeated a human participant in a game called Go. You can read about it. It was big news essentially, but it used reinforcement learning. So we'll look into this very briefly later on. So reinforcement learning, in reinforcement learning, we have something, we use a system which is based on rewards and penalty. So it's like training a small child. Okay, so let's say the algorithm takes the right step towards achieving the end goal, then we give the algorithm a reward. Okay, if the algorithm takes a wrong step, then we penalize the algorithm. So using this reward and penalty, the algorithm over a long period of time, it can train itself to become really efficient. Okay, so let me give you an example which will help you differentiate between supervised and unsupervised learning. It may not be a very good example, but at least I made an attempt. Okay, so let's say you are watching a movie in a foreign language. So generally, let's say you are watching a movie in Italian or Spanish, not in something which you don't know, or any other language. So generally, when you're watching the movie of some other language which you don't know, then as soon as the actor or actress speaks, the subtitle appears in the bottom. Okay, so you once you watch a 2-hour movie in that language, you kind of develop in your mind some kind of linkage that, okay, this word means this, because you are linking the word and the subtitle. So this is supervised learning. Now let's say we remove the subtitles, we turn off the subtitles, you just listen to what the actors or actresses are saying. So let's say someone says, in Italian, people say ciao to say like goodbye. So now what you see is, you see the person uttering the word and you see the action. So you have a context in mind that probably they're saying goodbye. Okay, so that is unsupervised learning. So you don't have information about, you don't have the complete information, you don't have the subtitle, but you have some kind of context, and using that context you try to make inference or conclusions. Okay, so that is unsupervised learning. So now semi-supervised, you can understand it's a combination of supervised and unsupervised, and of course reinforcement learning, which we already explained. Okay, so there's another type of learning called online or batch learning. Sorry, I wrote over this. So online is if it can learn incrementally or not. Let's say your data set is changing, it is dynamic, then you should go for online learning methods. If your data set is not changing very much, you can use batch learning. So okay, there's something called instance based and model based, but these are not. So these are some classes of or different types of machine learning algorithms. Okay, So reinforcement learning, as I said, in reinforcement learning, I tried to highlight this because there are two areas in machine learning which are like a lot of things are happening in this area. One is reinforcement learning, and the other one is deep learning, neural networks. So I will just give you a brief idea about this. Okay. So in reinforcement learning, the learning system or the algorithm is called as the agent. It observes the environment and selects and performs a specific task. Now, in return, if the agent has taken the correct task, then the agent is rewarded or penalized. Okay. So over time, it should learn itself to acquire most rewards over time. So this is the learning principle, or as you say, policy. So achieve or to acquire most rewards over a period of time. Okay. So that is the learning principle on which reinforcement learning works. So this is our, you can say, a cost function to acquire most rewards over a period of time. So to maximize our rewards. Okay. And that is reinforcement learning. So there are two areas. So if you are interested in machine learning, so these are two areas in which a lot of research is happening, or it's like you can say hot area: reinforcement learning and neural networks. Okay. So what is neural networks? So as I said, neural networks is a subset of machine learning. In neural networks, when people first tried to use neural network, they tried to mimic the brain. So in brain we have neurons. Okay, so these are the neurons, and in a neuron you have axons, and you have you have axon and you have dendrites. So in dendrites you have responses coming from neighboring neurons. Okay, so these are the inputs in a artificial neuron. So you have the inputs x0, then this input is multiplied by some weight w0, and in this way you have multiple weights w0 times x0, w1 x1, w2 x2. You can have multiple inputs and outputs, multiple inputs, and within the neuron all these inputs are summed. Okay, within the neuron all these inputs are added together, and you might add something called this constant is called bias. Some neurons might have a bias, some may not have, and essentially then we apply this function which is called as an activation function. So it's a very simple structure, and using this mathematical, let's say, linear formulation, we can approximate a large number of target functions. Okay, remember the target function is the unknown underlying process. So using a combination of neurons, many neurons and many layers of neurons, we can approximate many target functions, and it has been shown to do tasks many tasks efficiently. And also this AlphaGo is essentially also there is recently Google actually also developed a neural network engine which has been shown to perform almost as well as human beings. Okay, so in a neural network you will have an input layer comprising of these neurons of these structures. You may have one or more hidden layer. Okay, so if and then you have an output layer. Okay, and each of this there are some weights associated with this. So during training, so when we say we train a neural network, so essentially neural networks are supervised learning. They are not unsupervised, they are supervised learning methods, and they fall within supervised learning, and they use these inputs and outputs. They vary the weights within this neural network to train the neural network to perform a specific task. Okay, so that's how neural networks work. So okay, and these are some typical activation functions that are used here. Fine. So these are all. So if you want to visualize how neural networks work, you can use something called Playground or TensorFlow. So let's have a look at this. Let me share the window where you can have a look at Playground. Okay, so this is a neural network playground. If you want to understand or if you want to gain an understanding of neural networks, how they are working. My screen seems to be stuck for some reason. Let me refresh it. So from there, I think we do not have enough time, but I will briefly show you what are the tools that you can use if you want to work in AI/ML. So for example, now most of us are away from the institute. We are at home. So we can assume that we have low resource settings. We do not have a proper lab, or let's say computational resources, or let's say systems with GPUs present. So we can use these tools which are freely available and for our applications. So Python, of course, is free to download and use. So you can use Python-based tools. There is something called Google Collaboratory. We'll have a look at it. So Google Collaboratory is a notebook, a Python notebook developed by Google. It provides you with virtual space and virtual computing. So you can also use a GPU. I will show you today, and you can use this library in Python called scikit-learn for machine learning algorithms. And then there is something called Keras. So Keras essentially is an API which can be used to access deep learning libraries such as TensorFlow, Theano. So Keras is using this Keras API. You can use it for your neural networks application and deep learning purposes. So so there are two demos which I had in mind, but almost we are running, like we'll be going over time. So I will just show you the first one. This second demo is something from my research. We can also, in which we use some neural networks to analyze time series data. So essentially, this is a time series data. We wanted to detect this kind of pattern very accurately. So you can see that this is although the neural network is not working that well, it's a work in progress. So it is able to identify at least two peaks or let's say points which belong to this peak. So anyway, these are some. So I'll probably look into the first. I'll show you this first model. This example is available online, so you can also have a look. But I will give you a brief explanation of the process. Let's say someone gives you a data, or you have some experiment data. How to go on? Let's say how to prepare that data to be fed into an algorithm, and how we can use that algorithm to achieve a meaningful goal, or let's say to solve our problem. Okay, so let's have a look. Let's go to first TensorFlow. So this is a online visualization available, made by Google. Actually, it's available. It's called playground.tensorflow. Here you can see the neurons. So this is the input layer. These are hidden layers, and this is the output. So here the neural network is performing a classification task. So if I run it, it shows me many different things. It shows me the weight. It also shows me the connections that are made between these two neuron layers. So it's anyway what I'm trying to say that, and this is the classification result. So the idea was to classify the blue points as blue. So if you have an unknown point, let's say someone gives you an unknown point and you want to classify and you want to check whether it belongs to the blue or orange class, then this neural network can do it. It is trained here. You can see this, any point which falls within this area will be classified as blue, and any point which falls in this area will be classified as orange by the neural network. What I'm trying to say is this is a nice tool to understand how a neural network works. I think visualizations, I personally feel visualizations help a lot to understand. So I think this is a nice, useful tool to understand the workings of neural network in a simple manner. Okay, so let's have a look at I had some other examples in mind, but I think it will be difficult to run it given the time restrictions. So, okay. So this is a Google Collaboratory notebook. Okay. So in this Google Collaboratory notebook, if you type collab. So the link I have given here, collab.research.google.com. So you will come to it. And what it is essentially is all you need is a Gmail account to access it. Okay. So this is a notebook where you can run machine learning code. It's taking a long time to load. Maybe it's because of the video. Okay, I hope it loads up. Okay, fine. So here you can press connect. So let's say I want to start a new notebook. All I will do is just click new notebook, and you can have a notebook. And within a notebook, you have these sections which can help you. Let's say I just want to execute this line of code. Then I can write that within this small section, and it will execute that much line of code. But anyway, so here I can. So if I want to use a GPU also, I can do that. So GPU is not something all of us have at home, but yeah, using this tool you can use. So as I said, this is a way to start off with low resources. Nowadays we are all at home. So let's have a quick look at this problem where we are trying to prepare a model which can predict house prices. Okay, just very quickly, and then I will hand it over to the moderator. If you have any questions, you can ask. Okay, right. Let me go to the very beginning. Okay, so here these are some initialization stuff. So you can do import numpy as a library, and then you can do these initialization or write some initial functions to do some initialization. You can do some settings related to the figure so that the figure have certain size, the letters that appear in the figure have certain. So given a data, you can store that data in your Google Drive, and you can use this to mount. You can mount the data from your Google Drive. So it will ask you for an authorization code. What you need to do is this: just click on it. Very simple. Allow, and then just copy, paste. Because your data is located on the Google Drive, and this is a remote machine, let's say, and it is mounting it on the so the Google Drive is now mounted on the machine here. So you can see. So it tells you that okay, connected to Python 3 Google Compute Engine backend GPU with this much RAM and this much. So it is now mounted in that location. Okay. So there now I am loading my data. So I can use, so in Python we have something called data frame, which is within the pandas library. So if I want to read any data from Excel sheet or comma separated variable CSV, most of the experimental equipment that we have in the lab, it also maybe sometimes it stores data in CSV format or even .mat format, which is the MATLAB. Of course, MATLAB is not free, Python is free. So you can use certain Python libraries to convert these data types. So pandas is used for reading data from CSV or Excel sheet. Anyway, so this is the data we have. We have longitude, latitude, median age. So these are, let's say, different sectors or districts in California. This is a very popular data set called California Housing Data Set. People use it to explain the machine learning technique. And the problem, so let's say somebody has given you this data, you are working in a corporate data analytics company. Here you have been given this data, and people tell you that your manager tells you that you want, so you take this data, that is the existing data, where if you have these properties of certain district, you have you have this much median house value. Let's say one of your clients wants to make an investment in a certain district. So you want to predict the house value, then the manager tells you to develop a machine learning program or let's say algorithm, which can be used to predict the house price. Okay. So just very briefly, I will tell you what it is. So first you have the data, you load it up, you can visualize it like this. Okay. Using matplotlib .pyplot as PLT. So you can visualize this. So this is a histogram, and where histogram is, it tells you the frequency. On the y-axis you have frequency, and on the x-axis you have the parameter. For longitude, how many times it appears in the data set, and these things, this information are there. So it helps you to visualize the data distribution. So you can use histograms to visualize the data distribution. Okay, so you have many different types of data distribution. So here you can see it looks like a normal distribution, but it is slightly skewed. So all these information you can get through by plotting histograms. And it's really simple to do it because your data frame object itself will have, housing is a data frame object, and it has this function called hist, which can be used to make a histogram. So these kind of exploration, I suggest you do it yourself. So machine learning as such, if from an application point of view, it is not a very complex thing to do because there are lots of resources available. So once you visualize your data, so you try to understand some kind of linkage between data. So one simple way to look at the linkage is using correlations. So we'll have a look at that. Before that, I want to show you, you can also visualize this in using scatter plots. So there are certain functions in certain features within scatter plots which you can use to highlight areas where data is more bunched up together. For example, here the density of data is more, so it is appear dark, whereas the density is less here, so they appear light. So there are many features within Python which can help you understand, or let's say visualize the data very nicely. Okay, here we have plotted it, the data on a map of California. So anyway, next is once you have loaded up the data, you try to find out and you try to do some little bit of exploration. Don't explore too much into the data because that will result in overfitting within your brain. Now you will try to, now you look at the correlations. If you dig too much into the data, you will kind of develop your own correlations in your mind, and you will not rely on the mathematical, let's say, algorithm side or the backend. So what you will do is you will try to develop an algorithm which will fit your conclusion. So it's better not to do it, but just to have a quick look at it, because our brain is very good at overfitting. Let's say you visit Rourkela and one auto wala or one taxi wala charges you a very high price, then it is human tendency to make a inference that all taxi walas or all auto walas will charge me very high price if I travel from Rourkela station to NIT. So our brain is very good at overfitting. That's what I'm trying to say. So don't do too much exploration into the data. Just try to find out some quick, so get some good idea about some brief idea about the data correlations. So you can use correlation to find linkages between our target value. So this is our independent variable, median house value, and the rest are dependent variables. So it's showing that median income has very high correlation with median house value. So this is an important parameter to keep in mind. So why I'm saying this is important, because there is something called how you select your values is important. There is something called stratified sampling. Let's say you are conducting a survey in India. In India, we have a male to female ratio. So if you are conducting a study for both genders let's say all over India, then you need to keep in mind this kind of ratio in mind, so that let's say if you select 1,000 people, so that ratio should be maintained. Just an example. So similarly here also, you can also use, let's say stratified median income is an important parameter. So maybe you should apply stratified sampling to median income. So now what we do is, now we have this data. What we do now is we split this data into a training set and a test set. So let's see where we have. So okay, before we split it, this is important. Let's have a look here. So longitude, latitude, housing, median age, these are all different independent variables which are affecting my dependent variable, which is median house pricing. But these are all different units, right? These are all different units. So to make them comparable to each other, so machine learning will not understand, the algorithm will not understand different units, but to make them comparable to each other, we do something called scaling or normalization. So this is very important to keep in mind. So we can do a scaling or normalization so that all of these are comparable. So we will see later on, we will do scaling here. So it's a long example and we don't have time to go through all of it. So anyway, so after we do the scaling, our machine learning algorithm is ready to, so our data is ready to be split into a training set and a test set. So I'm just trying to search for the line where it is split. So basically, okay, let's assume that since we are running short of time, we split the data into a training set and test set, and you start off with some initial algorithm in mind, let's say linear regression. Okay, and then you evaluate the performance of the algorithm. So linear regression, so you have many different test parameters. For example, as I told you, there are two problems that we try to solve. One is classification and the other one is regression. So in classification, we use a metric called accuracy, which is telling us whether the object has been classified correctly or not. For example, let's say, if a person comes to you, you do a diagnostic test for COVID, for example, and then you make an inference whether this person has COVID based on the positive result or not. So that type of classification is actually, you can say there are true positive, true negative, false positive, and false negative. So accuracy captures that error metric for classification. And in regression, we have something called mean squared error or mean absolute error as a test metric. So here we have used mean squared error to judge our algorithm, how good it is. So based on our error metric, we can make a judgment how good it is. And then, so if we are not happy with it, we can try cross validation. So cross validation is a technique which what we do here. What we do in cross validation is, I can explain to you very quickly. So in cross validation, you remember we have a data set, okay, training data set. So essentially we have data. So initially we've split it into train and then test. Okay, so this training data set is further, when we do cross validation, let's say we do k-fold cross validation. Okay, cross validation. So if we say do k-fold cross validation, we split this data into k buckets. Okay, k number of buckets, 3, 4, 5, 6. If it is 4-fold, we split it into 4 buckets. So we have k buckets. What we do is we select one bucket, and this is done randomly. This entire process is done randomly. So data is selected in a random fashion and split into all these different k buckets. Okay, and then we select one as our test set, and the rest is we treat it as our training. So your algorithm is now trained on this data set, this 2 to k, and the performance is evaluated on this one. Then we repeat the process again. In this one, this will go into training, and the second one will go into test, and the rest again will be training. So like this, all these different data buckets go through a test and training, test, training, test, training. So the algorithm will, if you have k-fold cross validation, the algorithm will be evaluated k times. Okay, for every k time you will have an error metric. For every k of these k times, what you do is essentially you take the average of this error, and then you come up with the average error. And we can use cross validation to, as I said, to judge the performance of our algorithm. You can also use it to fine tune our algorithm. Okay, so almost coming to an end. Fine. So later on also you can use different other algorithms. Let's say you don't want linear regression, you can try some other algorithms. If linear regression is not working well, so you can try decision tree regression, or you can try random forest, or many different algorithms. So basically what we do is essentially we start off with data, we clean the data, we do scaling if needed. If there are in the data we have multiple variables with different units, we do scaling. Once we do scaling, we split it into train, test, and test set. What I forgot to tell you is this one. So this is split into train and test, and once we have, actually this will help. End of the cross validation, we will have the final algorithm which is selected. Okay, now so all this data the algorithm has seen. This set the algorithm has not seen. This is completely pristine or unseen data to the algorithm. So we can further validate the algorithm using this test. Okay, so this data set, we can again use it to validate our algorithm. So this is, let's say, unknown data set. So the idea in machine learning is that you try to generalize your algorithm. So if it is too general, then we call it underfitting, or let's say it will not work well. And then if it is too restricted to the training set, we call it overfitting. So these are two issues, underfitting and overfitting, and that issue we can solve using cross validation. Okay, so that's it. So after cross validation, you can do model fine tuning using cross validation. If you still want to do some more tuning, there are something called hyperparameters. Hyperparameters are, the name sounds very fancy, but essentially it is the parameters of the algorithm. Okay, so you can do hyperparameter tuning using there are some functions called randomized search CV and grid search. You can use this to go through a series of different values for your hyperparameters, and then you look at which value gives you a more optimum value of the error metric, and you can select that one. Okay, so I think I have overshot the timing by 15 minutes. So thank you very much. Now over to the organizers. That's all from me. So if you have any questions, feel free to ask, please. And sorry for going over the time. Yes.
Thank you, sir. That was like really an informative session. We may now begin with the questionnaire. I request all the viewers to please put forward their questions in the chat box.
Okay. Any questions that is okay, Kansham? How can it be used to find? Okay, so it's a very broad question. How can artificial intelligence be used to find cures of diseases like cancer and medical mysteries? Okay, okay, Ghanshyam. Actually, we'll start with Ghanshyam's question. So I will stop sharing the screen for now. Okay, fine. So you see, I'll give you an example. So cancer itself is a very broad field. Okay, let's consider a specific. Let's say we want to detect brain cancer. So essentially, machine learning algorithms can be used for early detection of cancer, and it can also be used to reduce the invasiveness of the diagnosis. So generally in cancer, you do biopsy, right? Biopsy in which you insert a needle and try to extract data, like extract, sorry, not data, extract some kind of sample from biological sample, and you do analysis. Now people have tried to do this without a biopsy. Let's say people try to. I'll give you an example of melanoma. Melanoma is a type of skin cancer, which happens on moles. So what people do is they try to take images of melanoma, and they train neural networks to differentiate between malignant melanoma and benign melanoma. Okay, and this neural networks, then what they do is they they take the and identify patterns which are common in malignant melanoma. So for example, in malignant melanoma, you have doctors also have certain kind of criteria in mind. So generally, it should be asymmetric, and it should not have a clear border. So the border is like zigzag, and then you have color difference within the same mole. Then you have diameter, which is abnormal, but I think ABC is one of the few parameters. And then there is something called E, which is ABCDE. So E is for evolving. So generally, if it is malignant, then it changes over time. It becomes larger. But anyway, these are something. These are some. So all these parameters, algorithms try to extract these parameters which are present within the image to deconstruct it and make a diagnosis whether it is malignant or benign. But first of all, I should also say that relying on the algorithm, algorithm can be used as an assistive technology. So it may help doctors work as an assistive tool. Let's say you have 10 people, as humans, doctor think, okay, these 10 people should have a biopsy. Maybe an algorithm can add an additional layer, and it will actually tell, okay, out of these 10 people, the algorithm identifies a higher risk of 5 people. So maybe these 5 people can be given priority, or can diagnose, or maybe sent for further analysis, or like biopsy or whatever. So it can be used as this is one example which I gave. There are many examples. So algorithms have been used for detection of breast cancer imaging, brain cancer as well. So many areas. Mostly image processing using neural networks. So neural networks are very good at image processing. If you have infinite number of, not infinite, but large amount of computing resources, there is no restriction on your computing resources, then neural networks is a good tool to use for image analysis for these kind of applications. Yes, next. Yes, so there is an approach. So so it is dependent on your application. So essentially, once you train a neural network, then you can use hyperparameter tuning. So in neural networks, there are many different hyperparameters, such as what you mentioned is one of the hyperparameters. A number of layers is a hyperparameter, and number of neurons in the hidden layer is a hyperparameter. And then, so these hyperparameters can be tuned with the help of hyperparameter tuning. And hyperparameter tuning is done using this function which I showed you, this grid search and randomized search CV function. And using these functions, you can do hyperparameter tuning, and it will help you optimize your neural network. So the answer to your question, yeah, next. What is the current acceptable error rate or error percentage in AI/ML algorithms? Okay, so there is no such, let's say, acceptable error rate. So it varies from application to application. In certain applications, you need your error rate to be very low. Okay, sometimes certain error rates are unachievable also. So it really depends on the programmer and the people who's using this algorithm for the error rate. I mean, there is no such, I wouldn't say there is an acceptable or there is a range. I mean, people say 95% and all that is there, but it really depends on the application. So yeah. Next one, please. Virtual laboratory practicals. Okay, this is something which I haven't thought of, and I haven't seen anyone doing it. It's a good idea. I don't know if you can use neural networks So maybe you can use neural networks to maybe you can use neural networks for specific tasks to. So I mean, to be honest, I don't know the answer of your question, but it's an interesting idea. So it's a step towards the goal of making a David. So yeah, I don't know the exact question, to be honest. Yes, you can focus on ensemble models, which is a combination of many different algorithms, machine learning algorithms being used together. It's a good approach, and it is actually used in a lot of different applications. Yeah, it's a good thing. But whether you should focus or not on ensemble, so there is no clear like one answer to all solution. It's not that, it's not like the Lord of the Rings that you have one ring to rule the entire everyone. It's not like that. So your machine learning is always application dependent. So yes, ensemble models is a very good approach, but it's not that it is useful for all applications. So yeah. Next one.
So the next question on the screen is it valid to use a GAN for data augmentation for medical data sets?
Yes, yeah, you can use GANs for data augmentation, and it is a very good idea also. So in medical data sets tend to be very, sometimes you have very less clinical data set. You can use GANs to generate, additional training data. I personally haven't worked in that area, meaning I have faced this issue in the past in machine learning that my data is not good enough. So, but I haven't got to that stage yet where I have been able to successfully train a GAN to generate new data, and the machine learning model as a result of this additional data has performed well. So I haven't been able to. It was one of the ideas which I wanted to explore, but I haven't been able to reach that stage yet. So I cannot personally comment on how good it will be, but of course, it is a good idea to explore, especially in medical data sets where you have limited data. Okay, this is a little bit hard to explain. I don't know, maybe dependent on computational resources. I'm not sure the answer to this question. Yeah, next one. Okay, again, this question is something out of my knowledge. Of course, I'm not very knowledgeable about these things, so difficult to answer. But I can tell you one thing. You see, I read a paper a few months back. Essentially, in that paper, I think it's not something very new idea, but still it's an interesting one. You see, the problem with chemotherapy drugs is that you have a lot of side effects, right? But it will be nice to develop something, so let's say, which can target the tumor cells or the tumor protein. So you can develop some medicine which will help in targeting those tumor areas or tumor cells or tumor molecules. Okay, so there you can use AI to come up with the right structure, or let's say chemical structure of the molecule, drug molecule, that will help you target, let's say, specific tumor molecules only. So you have a drug molecule. So in drug molecule development, you can use AI to come up with a chemical structure, and that chemical structure will help target will affect only the tumor molecule, or let's say the tumor cells. It will not affect any other cells. So I don't know, it is based on maybe chemical structure, how it will fit around the tumor cell. But yeah, so people have explored, people have tried to develop protein structures using AI, so that it will do targeted, let's say, delivery of medicine. Yeah, next. Okay, I mean, to answer your question, so what type of punishments? There is no beating the algorithm or anything like that. So actually, it can be just a mathematical parameter. Let's say you have two mathematical parameters, reward and penalty. So the algorithm should try to maximize the reward. So whenever the algorithm takes you can say reward plus one. Okay, so if let's say it takes a wrong step, then it will have penalty plus one. So the algorithm would try to like maximize the reward. So it will always have a reward plus one, reward plus one, reward plus one. And whenever it is getting a wrong step, it will have penalty plus one. Or it can have, let's say you have only one variable, reward plus one plus one plus one. But then if it faces a penalty, minus one. So let's say reward plus one, penalty minus one. Result is zero. So in that case, it can be a very simple punishment as such, like plus one and minus one. Or it can be, let's say you have you can have multiple rewards also. Instead of having just plus one, in certain step, in a more complex program, you can have plus one or plus 0.5 or plus 7.75. So yeah, there can be different flavors of how you can punish a reinforcement learning algorithm. The answer to this, I don't know, to be honest. Next question. Okay, so the steps to start learning AI. So first of all, you need to think whether you want to use Python or MATLAB. I would suggest Python because it is available freely. So you can first of all try to learn the basics of Python. Once you are confident with Python, then there are many online courses which offer you like some kind of lectures or videos through which you can learn machine learning. But try to select those online courses which have in which they explain to you in terms of examples. Like today I showed you some examples. So for, let's say, they are teaching you SVM, support vector machines, then they should have some examples implemented in Python which is doing SVM, so it is easier to understand. So yeah, I would say the step is first to learn Python, be proficient in Python. Once you have that, you may select some online course to get some basic idea of the AI, like of the field. Then there are some very good books which you can use. So there is if you want to gain a good understanding about this about Python, I personally use a book. So there might be other books. I'm not recommending. This is my personal experience. There is a book called Hands-on Machine Learning with Scikit-learn. So this is something which I also use. But there are many other books. I'm not recommending or advertising for this book. So these kind of books also you can use to get give you an overall idea, like a top level idea, then to learn more use books like this. Okay, so this falls into another area of computing called green computing. So it's about developing models which will use less computational resources. It's about developing computers which will consume less power. So yeah, so these are few areas in which there is no. I haven't worked in this area much, green computing. So I don't know, but of course there are. If you are interested in this area, people are there working in this area. So yeah, you can explore. Okay. Maybe there is a way. I haven't explored it, to be honest, or I haven't come across any such application where is being used to clean the environment. There are certain areas in which like people have used AI to understand the impact, or let's say predict the impact of climate change. Other than that, maybe if an AI identifies a certain area which is at high risk of climate change, then yeah, you can take some corrective steps right now rather than facing the problem in future. So these are some areas, some ways in which AI can help in getting the environment cleaned or better. Yeah, next question.
So, any more questions from our viewers?
Okay,
Sir,
so yeah, yes, sorry, Rashi.
no, sir. Like the next question is on the screen. How can AI be implemented in field of quantum computation, and how far are we from accessing full potential of quantum computers?
Okay, as far as AI with quantum computation, I haven't looked into that area much, but of course, it is an interesting area. I'm pretty sure people are working in this area. And quantum computing, how far? So I think there was one company in Canada a long time back which was actually developing a quantum computer. Then I think Google got on the boat, and I think Google is also extensively investing in quantum computing. So, but how far we are from accessing the full potential, it's hard to say, or at least I don't know the answer to it. But yeah, it is a very interesting area, and people are working in this area, and there's a lot of interest from industry also. Okay, Rashi, I think that's all for today.
Yes, sir. It was quite an
I
informative
hope
session.
you enjoy session. Okay, okay, thank you. And also, if you have any queries, you can reach out to me via email. So I'll be happy to answer your questions. Okay, over to you, Rashid.
Okay, sir. So with this, we come to the end of the first session of GenXConference, and I would like to invite the Vice President of Genesys Club, Miss Preeti, for the vote of thanks.
Thank you,
Over to you,
Rasi.
Preeti.
Thank you, Rasi. A very warm good afternoon to everyone present over here. I, Pritimai Sanapati, serving as the Vice President of Genesys, the Bioengineering Club, registered under Student Activity Center, National Institute of NIT Rourkela, is thankful to everyone present here. Our Honorable Professor Dr. Mirza Khalid Baig, all the viewers for taking out your time, and to my whole team of Genesys. Conducting an online conference was something we could not have thought of, but now I can proudly say that nothing can stop us from learning new things. In the end, I again extended my warm wishes to everyone, and I hope to see you all at your coming event. Thank you all.
Thank you. Bye.